All right, so 3.4 video form. We'll start out with talking about solving logarithmic equations. And the big thing, remember, between when you're solving exponential and you're solving logarithms, if you can't solve it the way it's written, switch it to the other one. And so let's go ahead and let's just start with example 6. And so it tells us to solve, and here's our problem. 4 plus 3 log base 2 of x equals 1. So the first thing we need to do is x is inside the log, so we need to get this log part by itself. So this is 4 plus and 3 times, and we know PEMDAS, when we undo an equation, we move what's being added or subtracted first. So I got 3 times log base 2 of x equals negative 3. And then we're going to divide by the 3 in front of the log. And so we know that log base 2 of x is equal to negative 1. Well, I've got the log part by itself now. And this looks like what we did back in 3.2, I believe it was. When we had a log and we were stuck, we switched it to exponential. So remember, this is log base b of x is equal to y, and we can change that to b to the y equals x. So we know our base is 2, our x is x, and our y is negative 1. So b to the y equals x. And so we get x equals, well, 2 to the negative 1. Remember, negative exponent, send it to the bottom. Now you have a fraction. So x is 1/2. And notice I boxed it, but I was like, whoop, I can't yet. Because remember, log has a specific domain. And so when we're solving with logarithms, we have to consider the domain. Remember, the domain says that we cannot take the log of 0 or a negative number. So if we have log of x, whatever that x is there has to be greater than 0. So we need to take this 1/2 basically, and we're going to plug it back in to that x. So when we look at that log, we had log base 2 of x. So plug in 1/2. So log base 2 of 1/2. Could we take the log of 1/2? We can. This number right there is greater than 0, therefore it's okay, which means that 1/2 is our solution. That's the hardest part on logs, is we have to remember to check our solution. Alright, so let's look at example 7. Example 7, same directions, we're just going to solve it, but it's a little bit longer here. So it says log base 4 of x plus log base 4 of x plus 1 in parentheses equals log base 4 of x minus 1 in parentheses plus log base 4 of 6. Alright, so we got a lot of log base 4s, and if we can combine any of them, that would help out a lot. So we talked about our rules of logarithms. And remember, when we're adding them, we can combine them by multiplication. So I'm going to combine this left side. So this is log base 4 of the x times the x plus 1 equals, and the same thing over here. I'm going to combine these. So this is log base 4. I'm going to take x minus 1 times 6, but I'm going to put the 6 first. Now, remember, with logarithms, we also had that one-to-one property that said if you had a log base 4 equals a log base 4, or as long as they have the same basis, then you can ignore them basically, because you already know they're equal, which means what you're taking the log base 4 ofs have to be equal as well. So that means that x times x minus 1, plus 1 has to equal 6 times x minus 1. And we're just going to solve. So x squared plus x equals 6x minus 6. Anytime, remember, you have x squared and x, you're going to have to set it equal to 0 so you can factor. So I'm going to move the 6x over, and I'm going to move the 6 over. So I get x squared. I have x minus 6x, so minus 5x, and then we have the plus 6 equals 0. Alright, so x squared minus 5x plus 6 equals 0. I'm just rewriting it. We're going to factor. So multiplies the 6 and adds to 5, so 3 and 2 minus and minus. Alright, set them each equal to 0 and solve. So we get x equals 3, and we get x equals 2. But now remember, because we had logarithms in the original problem, we've got to go back and check them. So I'm just going to kind of write it underneath the 3 right here. The first one was just log base 4 of x. Well, I can plug 3 in there, and that's okay, because that would give me log base 4 of 3. The second log I had was log base 4 of x plus 1. Well, that would give me log base 4 of 3 plus 1, which is 4, and that's okay. The next log I had was log base 4 of x minus 1. So let's plug in the 3. So log base 4 of 3 minus 1, well 3 minus 1 is 2, and that's okay. The last log we had was just of a 6. It's just a constant, so we don't have to worry about it. So 3 is definitely an answer. And so we have to check 2 as well. So let's do the same thing. The first log we had was just log base 4 of x. So that means we would have log base 4 of 2. That's okay. Then we had log base 4 of x plus 1. So I'd get log base 4 of 2 plus 1, which is 3, so that's okay. And then we had the last one there without the constant, log base 4 of x minus 1. Excuse me, so that's log base 4 of 2 minus 1. 2 minus 1 is 1. That's okay, because these are all okay because they're not 0 or negative. And then the last one was just log base 4 of 6, which is just a constant, so it wouldn't matter. And so both of these end up being our solution. Okay, example 8. It's just more of the same. It says using the product and quotient rules, we're going to solve. And so this time we can see that over here on the left side of the equation we have, I got two different bases there. They should both be a base 2. I just miswrote the first one. Alright, we have 2 log base 2, so we can combine them. They're being added, so we can combine them with multiplication. So log base 2 of the x minus 3 times the x minus 4 equals 1. And we could go ahead and do our FOIL. So log base 2 of x squared minus 4x minus 3x plus 12 equals 1. Combine those middle like terms. So x squared minus 7x plus 12 equals 1. Alright, but I can't do anything else right there, and I'm stuck in log form. But we know that our base is 2, our x is x squared minus 7x plus 12, and our y is 1. So when I go to set this up in exponential form, we have b, I said 1, but I wrote a 2 there, sorry. B to the y equals our x. 2 to the first is 2. And because we have x squared and x, we know we need this set equal to 0 so that we can solve it. So I got 0 is equal to x squared minus 7x plus 10. I can factor this, and I'll bring this up here to do it. And so when I go to factor it, I get a 0 equals x minus 5 and x minus 2. Then set them each equal to 0 and solve. And so we get x equals 5, and we get x equals 2. But remember, we have logs in our problem, so we got to check them. So I wanted to check the 5. My first logarithm was log base 2 of x minus 3, which means that would be a 5 minus 3, which is 2, and that's okay. My second logarithm there was log base 2 of x minus 4. So when I plug that x as 5 in, 5 minus 4 is 1, and that's okay. So 5 is definitely a solution. We also have to check the 2. So go back through your logarithms again. So you had log base 2 of x minus 3. When I plug in x as 2, 2 minus 3 is negative 1. That's not okay. We can't have 0 or a negative, which means 2 is not our solution, so only the 5 will work. Okay, example 8b gives us this problem here, wants us to solve it using the product and quotient rules. And so we see that we have two log base 2's that are being subtracted. And we know that we can combine if they're being subtracted using division. So we're going to write log base 2 down only one time, because remember we're condensing it, we're making it smaller, so we just write it once, of the top over, or the first, excuse me, over the bottom. And that's equal to the 1. Well, now we know our base is 2, our x is that fraction, x plus 4 over x plus 3, and our y is 1. So when we set this up into exponential, we get our b to the y equals x. Remember, 2 to the 1 is 2. Now there's different ways to solve this. The easiest to me is to put the 2 over 1 and then just cross multiply. So we'll write that over here. So when I do that, I get 2 times x plus 3 equals 1 times x plus 4, and then just solve this out. So 2x plus 6 equals x plus 4. You get x by itself. So move the x to the left. So I got x plus 6 equals 4. Move the 6. And so we get x equals negative 2. And then don't forget, you have to check. So when I come back, I'm just going to write this one above it. So when I come back, we know x is negative 2. So if I plug in negative 2 right here, is that okay? Negative 2 plus 4 is positive 2. That's okay. If I plug in negative 2 right there, negative 2 plus 3 is 1, and that's okay. So therefore, the negative 2 does work and is our solution. Remember, we didn't say that x could not be negative. We said that when we plugged it in, it could not give us log of a 0 or a negative number. So negative 2 is our solution there.